Okay, so we're going to do a brief overview about networking. Networking is a very important aspect of using computers in the modern day. Obviously, with the internet and being connected all the time is pretty much the norm these days. And networking and understanding some of the basic aspects, along with some of the tools for setting up and working with networks, is very important uh, to get started with technology. So we're going to touch briefly upon some of the key concepts. So we're going to talk a little bit about what is a computing network, what makes it up. I'm not going to go in too much detail because I myself am not an expert on this, but I will touch upon some of the building blocks and how you can use this to actually build out both a home network and then also speak to what an enterprise network sort of looks like and what the typical building blocks are there. I'll also cover a couple of useful commands. I'm using Linux, so most of these are Linux based, but you can see here the ipconfig and the ifconfig. They're sort of similar, although ifconfig has some different usages and options than ipconfig, but ipconfig is what you would use on Windows, and ifconfig is what you would use in Linux and Unix and the like. We'll also talk a little bit about ports and services, primarily in regards to firewalls. There's also the other aspect of encryption, which is not really touched upon much in these slides, but it is something which is very important to make sure that your data is safe. So what is a computer network? So a computing network is a method or medium for different devices to talk to one another, to transfer information. The information gets packaged into things like Ethernet is, obviously something that I think most people would understand and know about because that's the backend network of what everyone has in their home. It's the standard protocol that uses to get online. Ethernet is sort of like a holistic packet or the underlying technology that pushes the information, and then the information gets sent through TCP/IP networks over to the general internet, and then that gets taken along to all the paths. So when we type in www.google.com, then it brings up a website, and that website is a server located somewhere in Google's many data centers, and you have all the information. You're sort of good to go from there. All of this underlying technology is super powerful, but also very important and very complex, just because there's so many different pieces to it. We use things like routers, switches, and hubs to go online and jump between different types of computers. So you could have a computer located thousands of miles away, but because it can jump from one hop to another hop to another hop through this long stream of IP addresses, then you're actually able to go and you know see that website or access that web page. Um, but this is also true and important for other types of networks. You could have things like storage networks. If I want to save files onto an external storage, it also uses the network and uses a different protocol in between, or it's translating a different storage packet, for example, SMB, NFS, etc. Um, but all of this is made possible by the network in the back end, and it all relies on these types of networks. So almost no matter what you do in computing, is you're going to require a network in some form. So looking at the building blocks, just using TCP/IP. So TCP/IP is the transport protocol. It transports packets using the TCP to various IP addresses. So the IP of a particular computer basically is saying like this computer is located over here, and then TCP would then know, okay, I'm going to take this packet of information and push it over to that IP address. So it goes from one IP to the other IP. This is essentially how the internet and the World Wide Web is structured. There's many other layers on top and beneath this. So you'll have things like the application layer underneath, which could be HTTP, SSH, FTP. These are all different types of uh, things which then help grab and take the information and make it usable to the device so that you can actually read, say for example, a web page. Um, the transport layer here you can see is located in between these network headers. These network headers would be essentially like the Ethernet protocol. So if I was using a packet of information, sending it over TCP/IP, this network header could be Ethernet. There are other types of networks that you may use like LTE. LTE, the mobile data, that would be the network header for those types of devices. You could also have things like fiber channel, which is what they often use in data centers for like backend storage and so on. So there's many types of different network headers, and the TCP/IP sort of sits in between that network, and then it can transport the information, and then the information can be all different types of um, applications or information services or ways of sending information like HTTP, SSH. SSH is a protocol you can use to access computer terminals remotely and also send information. Um, and of course, many people I think would know about FTP or SFTP, secure FTP. Um, and then you have things like DNS, Telnet, etc. So all of these things come together, and then through the technologies, you can just sort of build up these layers. And the fact that they can be broken down and built up into all these different layers is really what makes TCP/IP and the internet and this sort of networking so powerful, because you can send all different types of information back and forth, so long as it's something which can then be contained within this TCP/IP protocol. We have things like the IP addresses. This is the IP side of TCP. The IP address, if you've seen anything like on your computer before, you could say like 192.168.1.150, whatever. That's what's called IP version 4. It's a 12-digit uh, a 12-digit number, and it doesn't have to show all the digits. So sometimes if you have a bunch of zeros, like this one right here would be 001, but in the IP address, they typically just leave that out. They don't need to show it to you. There's also IP version 6, which is 8 groups of 4 hexadecimal digits. It's a much more robust IP protocol, but oftentimes people still use IP version 4 for basic networking just because it's much more human readable. It's much easier to understand and much easier to set up. So when people are setting up things like static IPs or something where the IP is fixed, then setting up the IP version 4 is going to be a lot easier to understand. IP version 6 can also be concatenated or simplified. So even though it's technically 8 groups of 4 hexadecimal digits, it could also be simplified to 4 or 5 groups by using a couple of extra colons in between the numbers. So it's again, IP version 6, a lot of websites and things that are moving to IP version 6, but if you request IP version 4, you can still see the IP version 4. A DNS, a domain name server, allows assigning names like an IP address. Allows assigning an IP address to a specific name or domain. The domain, for example, like google.com, corresponds to this IP version 6 IP address. This was when I last did it, and we can show it again. So using the ping command in a terminal, you'll see from the information here, you can see, okay, it's getting information, these packets from this right here, and then this would be shows the corresponding IP address. If you were to copy this IP address and put it into a browser, you would see google.com. So you can sort of see that that's what it works out. And the reason my computer knows that google.com corresponds with this IP address is because my DNS or my domain name server recognizes google.com. It says, hey, someone's trying to search for this website or go to this address. Where is it? And the domain name server says, oh yeah, google.com. It's over here on this IP or this server. So it basically does the routing for you. DHCP, Dynamic Host Configuration Protocol. This is essentially what lets you connect to a coffee shop Wi-Fi and actually get online without, but just by, filling in the password of the Wi-Fi hotspot or the SSID. DHCP is a way for networks to dynamically assign IP addresses to systems when they try to connect. So when you log on to Wi-Fi and you have the name of the Wi-Fi hotspot and you're trying to log in and you enter the password, essentially your computer is going to the router or the whatever is network device is handling this DHCP and saying, okay, I would like to access the network. I've entered the valid credentials. The router says, okay, you look like a valid device, and here's a free IP address that no one's using right at the moment. And then it gives you the IP address and assigns it to this device, and then it identifies this address or this device by the what's called the MAC address, or the sort of a physical ID of the port on your device. So as long as you have that MAC address, then the DHCP will register this MAC address and assign it this IP and says, okay, this IP is now being used by your computer, so you can now access the network. So you have a valid profile, and when you're making requests, your IP will show up and say that you're making this request. A subnet. A subnet is also something which is really important. It's basically what controls how many available IPs are on a network, and it does it by filling up numbers. So the subnet, or what a lot of people might be more familiar with, is something called a net mask. Is essentially the net mask, when you put it in, it fills up certain numbers. So when you look at an IP address, you have these, in IP version 4, you have these 4 sets of 3 digits. These 4 sets of 3 digits, the maximum value that they can be is 254. Okay, for any one of these 3 subsets here, the max value is 254. When we set a net mask to something like 255, 255, 255.0, what that essentially does is saying, in this subnet, this protocol, the first 3 numbers all have to be the same. It would have to be something like 192.168.1 or .001, and then the other numbers on the back have a total of 254 connections that they can connect to. So we can look at this in another table. In these types of subnet tables, or this sort of subnet table shows you what available IPs there are. And the netmask, or 24, type 24, right here in yellow, is one of the more common netmask types. It gives 254 connections available to that network. And on that network, basically, if you set like a gateway, and you said, okay, my gateway is 192.168.0 dot 1 or whatever, then the net mask on the network would then say, okay, now this particular net mask, how many hosts or how many systems are allowed on my network, is net mask 24, or a net mask 255.255.255.0. And that means that any computer that connects with 192.168.1, go back to this address right here. So any computer that has these first 3 groups the same, and then this last digit is somewhere between somewhere between maybe 2 and 254, then that is a valid IP address. That's an IP address which can then connect to this network. If you set the net mask to something bigger, so if you set it to say like 255.255.252, that means you have 2 numbers, or 3 numbers in that third group, and then each of those third numbers can also have 254 different IPs that they can connect to. So effectively, you can have over 1,000, because you're taking the 254, and then you have 3 even more groups of it. You would have a total of four groups of it, right? So these are ways in which the network administrator can control how many different types of IP addresses can connect to the network and how many people can log on. And going smaller makes your network more secure, as less devices can then connect to the network. But sometimes, if you're running something where it's an enterprise infrastructure, you may just need lots of connections to be able to connect to your device. So there's plus and minus, and the network administrators will use different types of subnet masks to control which type of or how many clients can connect to specific devices and specific networks. It's a way of controlling what devices can go on the network and what can't. So looking at a home network is typically a fairly simple setup. You'll probably have something which maybe your internet provider, your ISP, just installed in your home. I think most people just use the default. If you have an extra networking router, maybe you needed better Wi-Fi in a spot of your house, then you might have another third-party network device, and this network device is then wired or cabled into the box from your ISP. But essentially, what this does is it allows for traffic to go in and out of the network, and then also on the local network. And the ports on a router are also nicely color coded, so you know which port is the port that's going to be an external port, or a port that goes to the World Wide Web or the WAN, um, the remote access network. And then it'll have maybe a yellow ports or green ports. Typically, is what you see on like Linksys and TotoLink and whatever. Um, and then the computers or the laptops or the tablets or the phones or whatever that connects to the Wi-Fi access point or is cabled in directly to the router, then has local IPs, which oftentimes could be this 192.168 and then dot whatever, and then they would be you could ping the other computers on the network. If you knew the IP address, you could ping it from another device, and then they would have this local permission to maybe share files between each other and do other things. And then they can also access the WAN because they're getting routed from this device, so that traffic from externally can then come in, and then this local network can access the external network. So, make a long story short, the router, what it does is basically sets up and accesses the gateway or the portal to the entire internet, and the router is basically handling all these local requests on your local network, but then also has at the same time access to the external networks or the WAN, so it can go and grab information that you're requesting from it. When you go into your web browser and type google.com or facebook.com or whatever. Now, on an enterprise network, it's a little bit more complicated, but again, it's just more layers. So on an enterprise network, what you'll probably likely have for particularly large-scale enterprises, they may have a physical device which acts as a firewall, so they don't just rely on, say, the built-in firewall of the router, and they don't just rely on the firewalls of the client computers on the network. They may actually have a physical device, which is a professional-grade or enterprise-grade firewall. They'll have that, which will be the sole gateway, or they may have many of these firewalls, which can then access the external networks and control which traffic can come in and out of their network. Then they'll have their network layer, which is probably a series of multiple switches and routers, which are linked together. But then they may have things that are like dedicated to backend, so you could have several different subnets. You could have 192.168.1.1. You could also have 192.168.167, which could be a separate subnet, etc., etc. So it becomes very complicated because you have so many different pieces, but all these pieces through networking can all also work together. So then underneath that, you'll have things like servers and storage in the back end. All of these are things which can then host this services and store data and run databases and run maybe like the email server for the company, or they could run maybe the company's website could be on here. The company website would be maybe running, like the actual application could be running on one of these servers, and then data could be then stored in this big storage box over here. Or you could have an internal like company or local organization chart, or for example, it could be something which is then hosted on a website on one of these servers, and then individuals in the company with access credentials can then log in and see things like the company org chart and new announcements and things like that in the company. Then you'll have the clients and the employees. They'll be connected to this network layer, and they may have like a Wi-Fi access point, kind of like the router that's in your house, and they'll probably have several of these Wi-Fi access points. And then the Wi-Fi access point could be a DHCP box, which is basically opening up the Wi-Fi portals for all the other clients to connect to it. And then this maybe has a static IP address on its WAN port, which then goes back to the firewalls, and it controls which information can then be accessed. Um, Again, you'll probably have something on the firewall which says, okay, anyone who connects from this router device with this IP has access to the WAN, and we set that up in the firewall layer. But all of my servers and my storage, I don't want them having access to the external networks because I don't want people getting any of our important data. So none of these IP addresses over here have access to the WAN, and that way you can control who has access to what and how you manage their data safety on an enterprise. And then the final layer is on servers and storage. What most networks and what most companies are doing these days is they're not actually running one server box, which is one operating system. They'll probably run several operating systems on the server box with a technology called virtualization. Virtualization is sort of like a middle layer um, that you install on a server, typically VMware or Citrix Zen or Red Hat KVM. There's many kinds of brands and services which essentially do the same thing. They allow a server to install multiple operating systems and multiple hosts. So one server through virtualization, you might have several different services. So I could have like my website, and my website has a dedicated system, and then I have maybe my database, which is running on another virtual machine. I have maybe a internal notification layer. This could be like a company's internal org chart or the company internal portal that could be running on another virtual machine. I might have the website for our company, if it's very important and can't go down, might be running on a couple of virtual machines. So I'll have the website or the web address is running on virtual machine 1. It's also running on virtual machine 2. If virtual machine 1 goes down or the server falls out, then through the DNS, which is probably running on yet another virtual machine, then the DNS will then pick up and say, okay, if anyone goes to companyaa.com, then we have a couple of IPs, and each of these IPs points to a different virtual machine. If one of the virtual machines drops out, no problem. We'll just route traffic to the other virtual machine, etc., etc. So there's many ways in which you can set up the system and make it sort of extra reliable. And virtual machine and virtualization is a great tool for companies to balance workloads, make better use of the hardware that they're running, and at the same time, it allows for greater redundancy and the ability to spin up and take down systems very, very quickly because you don't have to actually install the hardware. You just install the virtual machine and then get the virtual machine up and running, and you're good to go. So a couple of commands. I hope that was, I know I kind of flew through this, but I don't want to take up too much time. And I'll put more links to all of these types of technologies and so on in the blog post. A couple of commands which are just useful commands. So for example, if I type in ping google.com like we just did in the example, you'll see google.com comes up, but you can also do things like ping the actual address. So here in this example, this is running from a Linux box. When pinging google.com, the address it gave was an IP version 6 address. If you copy that and ping that address, you'll also see the same thing. You'll get 64 bytes of packets. And once you copy that in and bring it up on a website, you'll see exactly that google.com comes up, and we can just demonstrate that real quick. So this was the IP address that we got after pinging google.com. If we open a web browser, put in that IP address, assuming it didn't change, brings us up straight to google.com. So it just routes it directly over. And that's because we know from the ping command what the IP address of this Google website's running on. Another important command is ipconfig and ifconfig. This allows you to find the IP address of your actual host. And sometimes you'll have many IP addresses. So For example, when we're looking at this window over here, because it's a Linux box, we're using ifconfig. On Windows, you type ipconfig. If you type the ifconfig, you'll see, okay, we have our local Ethernet. It brings up this IP address. And then we also have a local which is a loopback, or sort of the actual default host. So if you had no internet connection whatsoever, and you would still have this 127.0.0.1 local host IP address. It basically, for internal services that run on your system, they need to be able to access your system locally, and using localhost or this 127.0.0.1, you'll actually be able to access files and services on your system that are running locally. So that's pretty much a given. If you run something like virtualization, or if you run something like containers or other services, they may create additional network ports or additional network systems that show up in the terminal. So if you were running something like virtualization, you might see something like virt.io, or another type of IP address, which is just a separate service running on the system. And then you'll see a whole bunch of more IP addresses. But essentially, this particular command is, if you just type ifconfig or ipconfig and you just want to know the IP address of the system you're running, this is the easiest way to get the IP address of your local system. In Linux, there's also a new command called IPA. It's not new, but I was forced to learn this new command after Ubuntu, I think, took away ifconfig in one of their updates. Believe it was 18.04. They removed ifconfig. Could have been earlier in a 17 release. I didn't check, but you can always then go ahead and install ifconfig if you still want that more familiar command. Most other Linux versions haven't removed ifconfig from the standard system. But again, if you ever want to check the functionality and you are running Linux, go to the terminal and type man, that particular command, like man IP for this one, or you can type man ifconfig. I can show right here. Man is just a way of bringing up the manual, and it's a text-based manual which you can then read in the terminal. So here you can see, typing man, we bring this up into the terminal, and you can read about all the different ways of using the commands. And this is true for virtually all commands. They'll have a manual, and you can bring that up and read through it. Pressing Q can quit it. arp-a is another really good command that I honestly just recently learned. It's a way of checking what other hosts and what other devices are on that particular local network. So when you're on a local network and you have sort of like network sharing open, then typing arp-a lets you see, okay, there are other hosts, or there's other computers on this particular network. In this example, we don't see one. It's just there's only a gateway. But if you're running something which is more like a complex network, or you actually have servers or file shares and other clients which are actually broadcasting their address and showing there's this additional computer located at this location, this is sometimes really good for networking. Particularly if you have like a server and you're not sure if it went down and you don't know the IP address, you can maybe try to use arp-a, and then you can maybe try to find, hey, maybe it's this IP address, and you can try to locate the system or access the system that way. So it's very useful if you're doing any sort of like back-end IT infrastructure work. And then my last slide, or second to last slide, I just want to touch upon the concept of firewalls. Firewalls are critical for network security. It's absolutely imperative that when you're running your system, you make sure that you have a firewall running. In Windows, it'll be turned on by default. In Fedora, it'll be turned on by default. In Ubuntu and Ubuntu variants, it's not necessarily turned on by default. So do make sure that when you're running a firewall or you're running a Linux box, you can type sudo ufw status, and you enter your password. and just make sure that the status is active. UFW by default is going to block all incoming connections to your computer, um, and allow all outgoing connections. If you're using Linux Mint like I am, you can also just check firewall. And you can also see the status there. So really important. Make sure that you do that. Um, but what a firewall does is essentially it can block incoming traffic, and it could even block some external traffic um, to like a PC or a client computer. And it does this with the concept both of services and IPs and ports. So there's IP addresses, there's also ports. The IP address is what we just talked about, that 192.168.1.1 or whatever it is. A port is what the service layer. So this is where we get to the application. The application in the transfer stack, different applications use different ports. For example, HTTP, it uses port 80. SSH uses port 22. FTP uses port 21 by default. So when you're looking to block certain traffic, these different types of applications will be sending requests typically on these different types of ports. So you may, for example, have some internal systems where, okay, I want to set up my firewall, but this particular server, this particular client, it's running a web server. So I do need to allow people to access my web server, so I may need to have port 80 and port 443 open, but I don't want any other ports open because I don't want anyone else accessing anything other than my website. So the way the firewall works is it allows you to allow certain ports or certain services to be opened. You can even, in some cases, set specific IPs. So you can set, say, like, I only allow port 80 open to clients on my network. You can set that using UFW or these other types of firewall services. So the firewall is very important to control or limit what traffic is actually able to access your device. And again, Windows and Red Hat Linux distributions, they don't use UFW, but they do have their own firewall technology. And as soon as the status bar goes away, you have the firewall D in Red Hat, and also IP tables. IP tables is the default for all Linux, but it's a little bit more complicated to configure. So a lot of distributions will use something which is a more similar setup, which is the reason why Ubuntu uses UFW. So in summary, networking is definitely an important and crucial component to understanding all concepts in computers. The entire internet is built up with networking, just many devices all connected together, and then using that one at a time, the entire world has become interconnected. The various computers and services connect by knowing the other IP. By putting in the IP in a system, you're able to bring up whatever service is particularly running on that specific system. And then things like DNS, or the domain name server, they help translate IP addresses into understandable language like www.google.com. And computers and networks can help protect against incoming unwanted access by using firewalls. I originally wanted to talk a little bit about encryption, sort of ran out of space and time. But essentially, encryption is making sure that the information which you're sending over, so for example, HTTP versus HTTPS, HTTPS is the secure version or the encrypted version of this data. It uses a technology called SSL and TPS, and that's the main way in which these types of services and so on can actually ensure that the information that you're sending is protected. Quick rule of thumb: always make sure you have this lock in the corner of whatever website that you're seeing, and it says HTTPS on the top. That way you know that information that I enter here in Google is actually encrypted information, so people in between can't see what you're writing. Again, don't want to go too into the weeds, but I hope this is a good starting point for you. And again, I'll put more information in the blog, and it's a really core concept. It's not networking, unfortunately, for myself. It's not something which I find extremely interesting in and of its own, but it is a very powerful tool. And having a basic understanding of networking is absolutely critical for anything you want to do in the technology sector with computers, because that's essentially how computers talk with one another. Even if you just want to do basic programming, as soon as you need to connect to something other than what's ever on your local computer, which is fairly frequently, you need to have at least a general understanding of networking. So I hope that this overview was helpful and gives you a good starting point to then go on and learn more as you need to and as you develop your skills. So as always, thank you very much.